All right. Okay, we got a long to-do list. We've made a lot of progress. We got PDHG solving the least squares problem minimization over a sphere, and that's great. And now today we're going to try to automatically set gamma, which is the purpose of this alternate form of the problem. We don't have to check. We don't have to guess what gamma is, what the regularization parameter is. We could just automatically set it. Okay, let's get started. I've realized as well that this is actually better. We do want an array of values for gamma. One for each coil. You know, maybe we'll talk about that, maybe we won't, but we'll certainly do this and then incorporate it into the problem and the reconstruction. The easiest thing to do would be to replace PDHG with line search. Sorry, to replace PDHG with line search. That'd be a very simple thing to do. And then that's slightly more, robust than PDHG. We don't have to worry about the line search parameter as much. I mean, about the step size as much. We don't have to worry about the step size as much. So let's do that. Let's start with something not too hard. There are these adaptive methods. So there are basically two different ways to try to set step sizes in optimization algorithms automatically that I can figure out. One is line search and one is adaptive. Line search means you try a step size, you see the result, and you use the result to determine whether you need a different step size. Adaptive means you do a step size, you do a complete update, and then based on that result for the next iteration of the optimization, you change the step size. It's a very subtle difference. Nevertheless, line search, in my experience, works well and adaptive doesn't. So if someone has any thoughts on that or why adaptive, how to get adaptive to work well, I'd be very interested. What is y? Why doesn't this take norm A? And what is y? The people that invented PDHG are Shamble and Pock. So PDHG is often called Shamble Pock. So y seems to be the dual variable, I think. What's the default value for tau? 1. There's a parameter beta. It's the default value for beta. 0.8. Speak that 1. Okay. I like tau of 1 over norm A much better. Nevertheless, right now it's 1. That's what we're going to write it as. The step size parameter that gets altered with line search default is 1. Now, again, what I don't like about comments is if I change that default, then I'm going to have to remember to change it in this comment, but whatever. Okay, so we're going to set tau equal to tau, 1 over norm A, and so this value will get changed in each step of the optimization with the line search. Just remembered I have an important meeting today, so I'm going to set an alarm on my phone. So I'm not streaming when I'm supposed to be meeting. Why cannot be reached? Oh, right, because optimization algorithm is set. Okay. There was a time when you had a character array as a value for a parameter in MATLAB. For some reason, you had to include that. I'm not sure why that is, but that's the case. So I always do. I'm not sure if that's still the case. That should never have happened, and that should be fixed. I don't understand why so many things are broken. We're passing in gamma. Let's see what happens. What bugs did we create already? I wonder what's taking so long to get here. And maybe we should just put that. Oh, I bet you it's the power iteration. Okay, maybe we should just put that in another mat file so we don't have to run it every single time. Array indices must be positive integers or logical values. What are you talking about? Opt iter is 1. Does it think G is an array? G is empty. Does PDHG with line search require G? This is the problem making variable name single characters. When you go searching for them, they're everywhere. What about F? Do I need F as well? Oh. Certainly if you're going to calculate the objective functions, the objective values, you need F and G. Okay, it looks like we don't need G, so we're just going to add in a check. If n arg out is greater than 1, which makes this, so if we want to output the objective values, if numl f is equal to 0, error, must supply f to calculate the objective values. Six seconds. Okay. Save norm a.mat, norm a. Okay, now much faster debugging. Don't always have to wait for power iteration to run. Now here, right, now we know that we must supply f and g if we're going to calculate the objective values. Not enough input arguments. Okay. And that's because we need to put an @ symbol for G. The reason we have to put an @ symbol for G and not F is the way it was defined. F is going to be an anonymous inline function, but G is actually a function, a non-anonymous, a named function defined within the function. So that's the difference. Still a bug. Index exceeds the number of array elements. N samples, you say? What is N samples? Image not is 256 by 256. G does not operate on that. Okay. Then what's the issue? Right, what does apply A return? That's the question. Surely it's the much larger thing, right? Right. MFS in is going to be number of samples in it. So then what's going on? Okay, let's find out. Hmm. Where's A? Here I wish there was like a file navigator. Fold. Can you fold all of these things? That'd be nice. Brave. MATLAB fold all. Can I collapse all in the editor like in the help browser? Collapse all. Do you guys see it? Place your cursor anywhere within the file. Go to the View tab. I see. That's fun. Now select Collapse All. No, Collapse All. Okay. All right, that didn't help all that much. Expand all. Okay. Wait, expand all. There we go. Fly A. Okay. What? Okay, A is an optional parameter with PDHG with line search. And if you don't supply it, it's empty. And if it's empty, it's just the identity. Okay, so I set this up so that if you don't supply A, then it's just the identity matrix, and that's clearly not what we want. F and G are just for debugging with the objective values, so I'm going to put those at the end with verbose. And eventually I might have something like if debug is equal to true, then do all this stuff where we're outputting the objective values with verbose, and if not, then don't output the objective values. Don't set verbose, and so F and G are just going to be not passed in. We're not doing that right now. PDHG with line search is running. These lines that are not indented are the outer iterations, and these lines within are the sub-iterations of the line search. And you can see with each sub-iteration, it's changing tau. I think with PDHG, there's a tolerance that you could supply so that if the relative difference between subsequent iterations is less than the tolerance, then it thinks it's done optimizing. That looks pretty good. That looks pretty good, my friends. I don't think I have that tolerance feature implemented in PDHG with line search. We could do that if we want to. That doesn't look as good as when we were using the regularization parameter lambda, I don't think. While this is running, let's check in the changes we made in PDHG with line search to work lib. Minor changes to the comments, and we added that check. Just say added check. We made it through the lambda. Now we're running this gamma. Oh, wait. Yeah, we're still supplying gamma manually. That probably explains the difference. Okay, that's the difference. One's darker than the other. And gamma's not as good. And that's fine because we don't yet have, we don't know. We did a little search at the beginning, if you remember, for lambda. We got a good lambda. I'm guessing if we changed gamma, like let's make it 0.1. I'm guessing if we change gamma, then we'll get a better result. I'm not sure. But I think this is the issue. If this works, I think we'll commit this change. We've now got PDHG with line search implemented. That was the easy thing to do, and then we'll go on to automatically setting gamma. Yeah, that looks much better. We're not seeing all those weird artifacts coming off of the ankle. This looks much better. Okay, so it is gamma. And that illustrates why we want to do this to do item. We want gamma set automatically, especially if we want to take advantage of it one per coil. It'd be very hard for a human to go through and search for a different gamma for each coil. It would take a long time. We've got PDHG with line search implemented. Let's check that in. I was going to keep it around, but I forgot. Oh. I don't want to check stuff in because I'm currently loading norm.a. Whatever. If you go to use this, you're going to have to delete that load line and uncomment out the calculation norm a.mat. Okay, leaving that there because we might use it again. Okay. Let's have find W, return a value for gamma here. So far we're using this. Now, gamma is a bound on the L2 norm of AX minus B, right? Sorry, gamma is a bound on this, W minus I times F times S. Well, to find W, we set up a linear system very close to this. So when we're finding W, we can just estimate these values. We don't have to do it within find W. Okay, what does find W accept? Just accepts K data for the ACR, for the auto calibration region. So we could do it outside of find W. If gamma is not set, then we do this. And that'll give us an estimate for gamma. That's what we're going to do. We have applied W here, which is what we're going to need. We only want to do this when gamma is equal to 0 and lambda is equal to 0. Or do we? Because in that case, we just run model-based reconstruction. So when do we do this? Okay, we only want to do this if neither gamma nor lambda was supplied. If num lambda is equal to 0 and num gamma is equal to 0, then do find gamma. Else do find gamma is equal to false. Something like this. So this is a binary flag that determines whether or not we find gamma. We actually need if gamma is equal to 0 here. It's just if lambda is greater than 0, right? What I'm wondering is, do I actually need this binary flag, or can I move this block here, maybe within here even? But then no, because lambda's needs to be a value at this point. Okay, do find gamma. So if neither is supplied, then do find gamma. This is like pretty clear code, semi. We could move it. At this point, we know that both lambda and gamma are empty, so we could put these set statements within here and then say, have more conditions on this branch, I guess. I'm just going to leave it like this. Okay. So we're here. We're not going to return gamma from find W. We're not going to do that. We're not going to return gamma from find W. Instead, we're going to calculate gamma. We're going to estimate gamma outside of find W. We don't need find W until we go to create apply W. Let's see if that all still works. Okay. We're still getting a good image out. Great. You can vectorize this loop. It'll require changing cert column. Did we do that already? Placing this with a BSX fund or something like that. I thought we had done that already. I guess something went wrong. But still, we could do that, and that'll make things faster. When it comes time to optimize, we'll do that. And we optimize a bit as we go, of course, but we don't optimize everything, like because, how many times have we deleted code, like large swaths of code? If we had optimized it, we would have just wasted all that time. So we optimize the big things to make debugging, a feasible process. This question is, do find gamma. And we only do that if we're here. Do find gamma is equal to true, and gamma is equal to, well, let's just write the code in here. Apply W, what are its arguments? It's not going to tell me. ACR? Surely. Right, we're actually going to use W minus I, so we'll do it here. Minus I ACR is equal to W applied to ACR. And here, lambda should be 1, right? Because in order for do find gamma to be true, lambda's got to be equal to 0. Just to be sure, we're checking lambda and gamma is non-negative, right? Yes, good. Okay. All right, what is this condition? So ACR is the K data, so for the correct X, it is FSX. So this is actually that. Let's take its norm. Okay, so gamma is related to the norm of this. Why isn't it just the norm of this? Because this is for all of K space. But this value is just for the ACR. So gamma is going to equal norm WMI ACR divided by the number of elements. Okay, we're going to do two things. Divided by the number of elements in WMI ACR times the number of elements in K data. Oh. This isn't right, because this isn't the norm squared. So let's make it the norm squared. And then we could square root. So if you want to see why I did that, write it all out. Let's do it together. The norm of x is equal to square root of x1 squared plus x2 squared plus xn squared. Right? Well, what if you need this value for a vector that has the same, norm squared property? Take away the square root, right? So what I'm saying is, suppose on average, this value, x sub I squared, is the same as y sub I squared for a vector y, which is larger than x. This is why I wanted to make, when we first set up gamma, I was thinking about making gamma not a value that bounds this entire norm, but rather that bounds this norm per pixel, the average value of this norm per pixel. Let's do that. So this is what I want gamma to be, where n is the number of pixels. Now we're going to have to change the actual functions. That happen, like these proximal operators. G is going to be nk data. Changing a lot. Changing a lot. Okay, so then prox of G2 is going to change. Or does it? Hold on. Hold everything. Now gamma is a different bound. Oh, right. Times nk data. Here I'm thinking of it like this. I think that does it. Now, before I forget, you might remember that at one time I put parentheses here when this code wasn't here. And that turned out to be a bug, right? Because we need to divide by norm in and then multiply the result by gamma, not divide by norm in times gamma. So this is but why did I do that? Well, what I'm worried about is it's going to take this array and it's going to divide each element of that array by norm in 2. And then it's going to multiply each element of the resulting array by gamma, and it's going to multiply the result of that array by nk data. So it's doing a whole lot of element-wise operations rather than just multiplying by one scalar, which is what I want. So how am I going to change that? Like this. Gamma times nk data divided by norm in 2 times. So now I'm sure that this scalar is going to be calculated first, and then that scalar is going to multiply each element of this array once. I'm hoping that still works. Let's test this. The issue with doing relative difference with PDHG is that the objective value is 0. I mean, it's infinity. So what's the relative difference between two infinities? Well, it's undefined. So I guess I won't be doing that right now. Okay. Code still runs. Looks worse though. Significantly worse. Right, because gamma means something totally different now. Bet you that fixes it. How long have we been streaming? About 45 minutes. Okay, back to a great result. Excellent. That, by the way, is showing us what you just saw is the difference between no SPIRiT regularization and some SPIRiT regularization. So you see it's, significantly helping. Back to find gamma. Where is that? Do you find gamma? Okay, so now the question is, I think that works. What happens if we don't set gamma? Well, we try to find gamma, so that's a good sign. Why did that fail? Huh. Apply W seems to assume that we're applying W to all of K data, doesn't it? We could replace this with, ooh, this is tough. Okay, so here I can use size in. Now this is no longer the adjoint, except when we're applying W to something of size an image, or S image. We're not going to call the adjoint of W unless we're applying W to something of size S image. We're only going to call this direct operation. So I think this works, but it's slightly confusing because this honestly is not the adjoint of this operation. So what to do? That's a pretty tough one. I can't do size in here because when we call the adjoint, the in that comes in is on the output of W, is the size of output of W applied to something. So I don't know what this size would be unless, like, ahead of time. I don't know. So two things to do that I can think of. One is just leave this like this. That works. The alternative is to set a parameter here called SW and have that be this. And so SW is equal to the size of the ACR here. And then once we get past here, SW is equal to the size of image. Is that cleaner or less clean? Now this always has the property that this is the adjoint of this. And another thing I could do is just make this size image and only change it to size ACR here. Which one's better? What's happening is that, really what this should take is the argument SW. But the way that functions in MATLAB work, like LSQR, let's look at A, for example. A can be a function handle, but it has to have this form. Oh. To use as a function handle, use the function signature function this. Parameterizing functions explains how to provide additional parameters to the function a_fun if necessary. The function a_fun must satisfy these conditions. So I guess you can have more parameters, but then how would you call it with more parameters? Use a nested function. One approach is to use a nested function like we have here, and then to pass in a parameter this way. Okay, so this is how they suggest to do that. This is how MATLAB suggests to do that. I guess we're going to stick like this. We're going to change SW for apply W. And we're going to change it back to the size of image. What value of gamma do we get? 0.0472. What value of gamma was this? 2 times 10 to the negative 7. Those are drastically different. So I think there's something wrong here. Maybe. What result does this give? I think this is going to be very noisy, and I guess we're going to find out. I have so many thoughts flying through my head right now. It's difficult to like explain them all. Very noisy. Not good. That's bad. Okay, we need a much smaller gamma. Why did this happen? Let's look at applied and W. What size is this thing? Why isn't my hovering working? Because MATLAB only kind of works. 19 by 19 by 8 by 8. It's way too many elements. But then if I reduce this number of elements, it's only going to make gamma get larger. It didn't? It got smaller? Because of the square root. Okay. Wait. This got smaller than it was, right? Oh! No. Wait. Before we had num L of that. So what is this? 23,000. What is this? A much larger number. Right, because this should have been that. Right, okay. Pretty tough, pretty tough. This N coils right here, we're going to have to face when we try to change gamma into a gamma array, one per coil. But for right now, this is what we got. Now, this doesn't surprise me, actually. If we go to find W, I want to step into this loop. We can't step into a for loop, so I'm going to change into a par for loop. So instead, I'm going to change it into a for loop so that we could just step into it. Making A for this coil. Go through and create the linear system. Calculate the solution, W coil. These are going to be the interpolation coefficients. Here, W coil is just a vector. So now let's take the norm of A times W coil minus B. And B here is just for one coil, right? Right. we end up with that. That's way larger than 1 times 10 to the negative 7. What's the square root of that? Just so I know. Yeah. That's not good. So it's 0.0068. So that's the error that we expect out of this. So why do we need such a much smaller regularization, a much smaller constraint value, a much smaller gamma in order to get a good result? One answer is that I'm sort of assuming that the statistics of the error inside the ACR are the same as those outside of the ACR. That isn't necessarily the case. And if it's not the case, then setting gamma in the way I'm intending to do so, where I'm using the ACR as a surrogate for all of K-space, won't work. And that makes me sad. Let's see. So I'm going to try this. We're going to do a model-based reconstruction on K data. That model-based reconstruction is going to be a surrogate for the truth. Alternatively, I could just actually use the truth. So instead of passing in K samples here, I could pass in K data, all of K data. That's what I'm going to do. Okay. So here SW is S image. Great. Let's look at the value of gamma here. Where is this? Why is it running? Because I put it inside of do checks. That was silly. What's gamma 2? It's large. Why is it so large? Here K data is the fully sampled data, right? Whose sample mask? Stats. This should be just straight zeros, and it is. Min 1, max 1. They're all 1. Right, because they're all samples. This should be straight ones, I should have said. I'm forgetting the wait, no, I did the minus I. Oh! No, I didn't. No, I surely didn't. What's gamma? It's even larger? Are you insane? The result of applied W minus I to the ACR has a mean value of 0.07, a median value of 0.04. Now, applied W has a median value of 0 and a mean value of 0.01. That doesn't make any sense. If I applied W to data, I should get back the data. The norm squared is 8 before when I apply. Now that if I applied to, oh, that makes sense. So now what's gamma? 0.01. What's gamma 2, I mean? 0.003. Okay, that's much smaller. So with K data, it's correct. Where is this fine gamma stuff? Okay. This is something I shouldn't be struggling with. Either things are really, really weird, which I doubt, or I'm just making a silly mistake. Another silly mistake, because I already forgot to put MI there. Okay, so in the ACR, the norm of applied W minus I is 51. And the norm of just apply W to the ACR is 51. What? Oh, that's 353. And that's 51. So it's much smaller to just apply W. This doesn't make sense. When we're doing find W, go back to this. We come in here. That. The norm times W coil minus B squared. That's apply W minus I. It's tiny. That's the sort of apples I'm looking for. Is it because we're doing a circular convolution? It must be. It's because we're doing a circular convolution. Apply W does a circular convolution. And when you do apply W to all of the K data, circular convolution does not have that much of an effect over a non-circular convolution because the kernel is small compared to the entire size of K space, and the values out at the edges of K space are much smaller. This means that the way to do this is to find gamma from within find W. That's what that means. Where does find W happen? What is that? Value assigned to variable might be unused. Why is that not that? Because we don't have an S there. Okay. What is gamma squared? You see the difference in these sizes? All right. See the difference in these sizes? That's why it's better to have 1 gamma per coil. What does gamma turn out to be? Large. Very large. Because I forgot to subtract B here. Now we're talking. Okay, we're starting to see values that we're interested in, but this is 1 times 10 to the negative 6 now. Like, this is on the order of what we want, but when we take the square root, it goes back to being large. 1 times 10 to the negative 3, which is better than what we've seen, but still not great. I'm wondering if I'm using gamma correctly once I figure it out. Like, we changed stuff in here related to gamma. Did I do that wrong? That should now be times n. So like this is divided by n, right? Take the norm. Oh, divided by square root of n. That should help a little. But that, okay, I'm thinking now the problem is how I'm using gamma in this function. So gamma, let's say it's 1 times 10 to the negative 7, which is what it should be. Like, I think this is right. It's the indicator function of whether the norm. So here I could actually do nk data, divided by nk data. And it's not actually nk data, but the square root of nk data. Okay, so now I'm wondering if I handled that correctly and find w. We're dividing by n here, and then we're taking the square root. So we are taking the square root of this number of elements. And we also need to divide here by the number of coils. Now what's gamma? I guess it's about 8 times smaller than it was. Times 10 to the negative 4. Okay. That's feeling reasonable. Oh. We want to take the average of these gamma squares, not just the sum. Is there a mean? Sure, there's a mean, yeah. So I guess I could just take the mean here. Probably I should, except this makes it clearer why we're doing stuff with n coils later. I think. Okay, so now minimization over sphere. Let's look at how we're using gamma. This is tougher than I expected. I think that's correct. I do think that is right now. Right now, I think that is right. The issue comes down to this proximal operator. What does that do? There seems to be an issue because we remain within the feasible set the whole time, which is why we're getting an objective value that's finite. And that objective value is not really going down. That looks pretty good. Not as good as before. Okay. It's very possible that's working. And the reason it doesn't look as good as before is because we're sort of taking the average value over all coils rather than just one value per coil. rather than making gamma a value per element in K data, which has one element per coil, we're going to check this in. That's what we're going to do. I think we did one of our to-do items. Find W returns a value for gamma. Huh. There's recon spirit and recon spirit reg in here. Commit find W now returns a value for gamma. I'm going to do something else. Offline, I went and compared MRI recon spirit, the version that I have versus the version that's currently in my repository, which my student Alex wrote. They generate, I didn't check bit for bit, but they generate the same results. So, but mine's a little more efficient if if the bound is 0. So I'm going to move MRI recon spirit to a different repository. I'm going to put it into dwarglib. Replace it. Good. Now git, well, this is a little scary. What? Oh. What? Your branch is up to date with origin master. I see. Move MRI. Okay. Over here, I called it recon spirit, all lowercase. And over here, it was called spirit, MRI recon spirit, in the way that it was. Oh no, I don't understand what's happening. Recon spirit. Changes not staged for commit. Modified recon spirit with a capital P, but it doesn't exist. Okay, we still have the function here. Good. I'm going to delete anything related to spirit here. What did I do? No changes added to commit. Use git add. Git add MRI recon spirit. Git commit on branch master. I don't know what happened. Okay. Git check out MRI recon spirit. Git status. Okay. Git move MRI recon SPIRiT to MRI recon SPIRiT, git commit, changing name of MRI recon SPIRiT to MRI recon SPIRiT. Okay. Now I can copy this, put it here. There should be a ton of changes. Made MRI recon SPIRiT more efficient when epsilon equals 0. Okay, now we can remove it from here. Moved MRI recon SPIRiT into worklib. Okay, good. That should still work because this line, if we uncommented it, should still work because MRI recon SPIRiT's now in the worklib and it's gone from here, which is kind of neat. We did something. We did something meaningful. Now we're back here. Now we're going to go back to gamma. So remember, W is a 4-dimensional array. So this is what I'm going to do. Now gamma is the value per coil. Take all of these gamma squared. I guess, you know what? This is the number of pixels in the NCR. That's the number of coils. Gamma squared is now a value per pixel, not per pixel per coil, but per pixel. This will be better because, hopefully it'll be more robust to using different numbers of coils. That's the idea. Okay. So how do we use gamma, right? I just want to make sure, see all the places where there's gamma that isn't in a comment. Okay. There's gamma is being found, and now we're going to use the thing. Okay. So here, I want to call this an image. Pretty tough, pretty tough, pretty tough. So what is this indicator? So the point is that, what is this now? What I want this to be is n pixels, where n pixels is the number of pixels in the image. That is n pix equals product of S image. Okay? Is that what gamma actually is now when we find gamma? They require a function argument. N_arg_out requires a function argument in par for loop. What does that mean? N_arg_out. I need n_arg_out check. N_arg_out check. Validates the number of output arguments specified in the current function call. It throws an error. I don't want that. Okay. What is, does n_arg_out accept a number of parameters? In terms of number of outputs that appear in the function, in the fun function definition. So what is fun? Function handle. Can I do this? Two. Sure can. Sure can. Okay. Oh. But what if we're calling this one? Got to put in the display. how does it know how many output arguments I'm calling with it? Yep, that's a bug. Okay. This is not an issue. Find W is always going to return gamma. Just trying to be a little more efficient. And now I'm not. Problem line 221. Okay. This function will always calculate gamma, but we're only going to save it and use it if we're actually finding gamma. Everything works just fine. Back to minimization over the sphere. We've been at this almost 2 hours. Time just flies. Time flies when you're doing fun stuff like this, don't you think? So this is going to be npix now. Does this not have S image? It does. Nope, 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 nope. Oh, wait. Yep, 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 yep. That's what I want. Or is that what I want? Yeah, that's what I want. Okay. That's what I was going for. Maybe. Isn't that the same as that? Because nk data is just npix times n coils. Yeah, that is what I want. So there's nothing to change. I think. Then I think there's a problem. I think there's a problem. Oh shoot, I'm gonna have to go through and fix all that again. It's all right. Does that run? Looks to be running. Okay. Why do I say there's a problem? It's this that I'm confused about. Okay, this might be so there's nowhere in here. We're dividing by the number of elements of B, are we? Okay. And now what's gamma? Times 10 to the negative 5. Okay. I think that was an issue. Guess I should make sure the image turns out nicely before committing something. Okay. Looks pretty good. Fixed a bug in how gamma was getting calculated. Are there more bugs in how gamma is getting calculated? Take the norm values squared, divide by the number of elements in K data, which we don't have here. And ACR is equal to num-L ACR. And ACR. Okay, wait a second. Should we be dividing by the number of elements in W coil? Because there's actually just one B per pixel, not per pixel per coil. Luckily, I committed the change saying I fixed the bug, so there can't be any bugs left now. Okay, So we were dividing by the number of coils here before. That's not what I wanted to be doing. We do need to divide by the number of coils here. Unfortunately, by not dividing by the number of coils here, which we were doing before erroneously, gamma is going to get larger. How much larger? Let's find out. 5 times 10 to the negative 4. Not a big deal. Not a big deal. I, of course, would prefer it smaller because I know that makes a good image, but that doesn't seem like a big deal to me. Okay. The next thing is, do we divide by the number of coils inside here? I think we do. Now let's make sure we're using gamma correctly. We have 1 gamma per, gamma is the value per K data. Is that what we want, or is that what we want? Right? Are we using the wrong indicator function here? Do we actually want that? I think we do, actually, because that's the way we're calculating gamma. Okay. If that's how we're calculating gamma, I want to do that. That's the indicator function G2. Now we got to calculate the proximal operator. Well, this is equivalent to, take the square root of both sides, into less than or equal to square root of gamma times n. I think that's going to help. It's going to be tricky to turn this into 1 gamma per coil. Realized a bug. Since we're now calculating that. And the issue is here. Now gamma is a bound on the sum squared. I think that's going to help too. Uh-huh. I don't know what's an appropriate value now because we're changing how we're using gamma. We have changed how we're using gamma. Okay, but here, yeah, right. So I don't know. Let's find out. Let's see. Looky there. That looks pretty nice. Okay. Okay, now I really fixed a bug in the calculation of gamma. Do we do more work on this today? Because the next step is to find a value of gamma for each coil. I'm in the mood, just in the mood, want to do it. Now, you might mistakenly think that a to-do item needs to be done. To-do items should really be called like suggestions. I don't know that I'll ever do this, but I want to have a note in case to remind myself that I could. I call those notes to do. Let me get rid of these. Okay. Find the interpolation coefficients W. These are no longer gamma squared, but just gammas. And this no longer returns a gamma. Instead, it returns gammas. Is it as simple as that? We were summing gamma squared before and divided by the number of coils. We're taking the mean value. Now we're going to have a different gamma per coil. Great. That was simple. Now find W is going to take gammas. Ooh, okay. Find W is still going to take gamma. And so the change is going to come, we could call it gammas, but what? We could call it gammas, but if you're supplying a value by hand, you're likely to supply a value to this problem, not the other. So we're going to call it gamma so that it turns out to be, what you would intuitively think of when you're called a function and you supply a regularization constraint value. Let's write the equivalent problem here. Subject to so here I mean the Seath sensitivity map, and here I mean the Seath element of gamma, or the optional inputs. We don't have any descriptions of optional inputs. We could similarly have a different regularization parameter per coil, but there's no way to set those automatically. Humans would never supply an array of lambdas, I don't think. And so I think this is all I'm going to do. I'm not going to do that. That doesn't make sense to me. So let's write lambda either empty or a scalar, non-negative scalar. If non-empty, then solves problem involving lambda. Then this function solves the problem. I feel like I revert to some very broken English when writing comments in code. I'm not sure why I do that. Okay, so now find gamma returns a value per coil, but I don't have a way to, it's not currently using it. So now what? The sort of simple way to modify this is to say if nml gamma is equal to 1, gamma is equal to gamma times 1s and coil 1. We don't have in coils yet, or is it? Wow. Have we used gamma before now? No. Okay, this is good. Is scalar? To improve performance. I like performance as much as the next guy. I appreciate MATLAB trying to help me out. I don't think we're going to get a big performance boost out of that one. Seems to be rather extreme to have like both highlighted and underlined. Whatever. Thanks, MATLAB. Okay. If the number of elements of gamma is 0, just make a whole bunch of zeros. Else, if scalar, oh, but now down here we have this. Don't we have a whole bunch of if statements involving gamma? Like right there. Max of gamma is greater than 0. Max of gamma is equal to 0. Max gamma is equal to max of gamma. Think that'll work? And here, this is going to be gammas. Okay, so what is the indicator function here? Now we're going to say divided by, wow. The issue is that now we've got a different indicator function per coil. Do you have any coils yet? No. You never have N coils in this code. Okay, well, let's change that. If norm of N2 here, N2 is AX, right? Oh, man. I'm very confused at this point. And I might just undo everything I just did. Oh, it's not AX. No. It's MFSX. That's what comes into G2. So this has size of K data, which means I could do this. If the norm squared of N2 divided by N pixels is greater than gammas of coil index, then return infinity. And return 0. Oh. Out is equal to infinity, return out is equal to 0. So this should be n pix, where npix is the number of pixels in the image. I want the original G2 back so I can see what it was. That was the original G2. I was dividing by the number of K data. But here we were calculating the norm. This is the norm of N2, all of N2, not just N2 for a given coil. So this makes sense to me. Okay, where was G2 being called? Right there. Great. So that's G2. G is still correct now. These G2 is the sum of a bunch of indicator functions, right? Sum over C. There should be a sigma, if I could do a capital sigma, indicator of N2 gamma C. So the proximal operator of G2 is going to be we're going to use the separable sum property of proximal operators. Out is the same size as N2. Or coil index equal 1 to n coils. Guess I'll use coil index. I'm sure whatever somebody did, like there's some way or if you could hit command or something and use what would be the scroll wheel on a mouse, it changes the size of the font here. Somebody at MATLAB thought that was a great idea and they spent a whole lot of their time implementing that. In my life, it just arbitrarily changes the size of the font, and it's very, very annoying. Okay, so here's coil N2 is equal to N2 coil index. Let's make sure that wasn't an issue with the implementation of G2. See this norm? That was going to do a matrix norm. Still doing a matrix norm. Got to vectorize it. You can add fro, and maybe that was the right thing to do because right now it's doing a major copy. In fact, that was the right thing to do. Let's do that. Fro, which calculates the Frobenius norm. So that's like vectorizing it and then taking the L2 norm. Okay? All lowercase. Same thing here. Hmm. I think that's right. I haven't run anything, so there are no known bugs, and that lasted less than a second. And picks. Using zeros. Size vector should be a row vector with real elements. Prox G2, what's the size of that? Okay. No. Huh. Oh. No. Whole bunch of bugs. Where does proxg2 get called? Let's say proxg. Then it gets concatenation. Okay. Back to the infinities. That looks pretty good. If we compare it to just model-based reconstruction, which admittedly is much faster, wow, negligible difference. And I was cheating. Oh, model-based reconstruction is cheating too. Okay. Okay. Let's try again. Hold on. Okay. That is model-based reconstruction. And that is recon spirit. And model-based reconstruction is better. Ever so slightly better, but better. Which indicates that there's a bug. There is a bug in recon spirit. Let's see if we can figure out where it is just in minimization over the sphere and how we're using gammas. is this doing this? If any one of these is infinity, then the sum is going to be infinity because the only two values possible are 0 or infinity. So we search over the coils, and then if the Frobenius norm squared divided by n pix is greater than gammas, the output's infinity. And we return. Otherwise, the output's 0, and we return. That seems to be doing what's there. G just takes the sum of G1 and G2. So the only other issue in how gamma is being used, there are two possible places where there could be a problem, where gammas is being calculated and where gammas is being used. Let's see if we think there's an issue here. Is this the same? For any single coil, let's call this Fro, which is just like the L2 norm. So for any single coil, that looks to be the same to me. Okay, so we're going to go through these coils and set out, oh, forgot that, did we? It's so irritating to see objective values here that are infinity. It's like I can't tell what's happening during the iterations. While it's running, let's see if we can find another bug. So if the norm of in coil is less than or equal to the square root of gammas of coil index times n pixels, then set the corresponding portion of out to be the same as in. Otherwise, take into, for that coil, and so divide by the norm of, which one's which now? That's figure 2, so that didn't get any better. We fixed a significant bug and things didn't get any better. I really don't like it when that happens. So taking into and dividing by the norm of into coil, taking just into for that particular coil and dividing by the norm of into coil sets its magnitude to 1. It becomes a unit vector. Then we multiply by the radius of the ball, which is the square root of gammas times coil index. Let's call it ball radius. Let's just call it this. I'm thinking, we're doing this multiplication twice. Ball radius. Ball radius is equal to. That makes it obvious. Take into, divide by norm makes a unit vector, multiply by the ball radius, it puts it on the ball, on the boundary of the ball. sets the corresponding portion of out to that. Do we ever get there? Okay, that's weird. Where is the objective values calculated? Right at the beginning of the iteration. I don't understand how. Right now, I don't understand. I mean, I have a hypothesis, but right now I'm questioning why, if we never get into that particular part of prox G2, which is why fixing that bug didn't actually fix anything. We're still getting objective values that are infinity. So where does prox G get called? It's actually the prox of G conjugate. Prox of G conjugate calls prox of G. So into, according to into, it's never, at this point, into is never greater than the ball radius. And that suggests to me that gammas is being calculated poorly. We're determining gammas poorly in defined W. I don't see any other bug here. Like I say, there's only two places where there can be a bug in how we use gammas or how we find gammas. So let's look at how we're finding gammas. And we're back to this. B has 225 elements and NPIX ACR has 361. That's because that we're only using the values in this linear system that are within the kernel, within the ACR, the ones where the kernel completely lies within the ACR. We're going to have one gamma per coil. So there's only two lines in this entire function that uses gammas. This one, where we have one gamma per coil, which we knew is correct, and this one. Where's the value in find W? There, okay. This is what I'm looking for. So did we change this? Norm, why is this changed? Because we changed from gamma square to gamma to gammas. Okay, that's the only change there. What I want to see is how the values of gammas that we're estimating compare to the value of gamma that we were using before. Okay, so gammas are this value. gamma is this value, much smaller. I expected this to be about the average of these, but look, it's a factor of 10 smaller. Why? Because n coils is about 10. No, like gamma is just the mean of gammas, right? Oh. Okay, I was right. This is the average of these. I was getting confused because this is 1 times 10 negative 6. I thought this was 1 times 10 negative 7, basically. That was silly. Those values are about the same. If I set gammas equal to this scalar, are you telling me it's going to work? Is that what you're saying? All right, find W. We do this up here. So now I'm returning the same scalar value of gamma that I thought we did before. And we're going to see what the result looks like. Now, probably I've been cheating here a long time, and this was K data where it should have been K samples. But here I think we've always had K samples, and if we give it this value, I think it gives us a good image. That's what we're going to check next. That's model-based reconstruction. That's SPIRiT regularization. That's bad, worse than model-based reconstruction, indeed. Okay. Now I'm supplying a value of gamma, the value that gave us what I thought was a good answer before. We're going to see what value of gamma we need for that. I think that we've changed the definition of gamma, right? Instead of taking the ball, instead of a bound on the ball, it's now a bound on the ball squared. So we may have to change the value to get a good image out. Yep, that's a bad image out. Okay. What if I do like 1D minus 3? Okay, we have found a bug. What's the bug? That, I guess, is the first time we've hit this line. Norm in coil 2. You guys thinking what I'm thinking? Looks like that's at least a significant bug. What was it doing? What on earth was it doing? Let's go back to having it automatically find the answer. Oh yeah. We're just setting the norm value, which should be the scalar to an array. How did I not see that? How did I not see that? I'm getting hungry. I think these are very different step sizes. Not sure. Don't remember. Look at that. That is pretty. That is very pretty. Oh, I like it a lot. It even seems to get some of the details better here. Let's see what the truth gives us. Okay. I think I forgot something. Oh, I know the issue. Okay. This is spirit recon. This is truth. There are some shading differences which don't shock me. You see right here? You see in truth how this bone curves around and this line goes like this? We seem to get that line pretty well with the spirit reconstruction. How about with model-based reconstruction? There's a subtle difference here. Let me show you. You see how we get a little bit more of this line right here? Which is in the truth. Better than nothing. What about all this stuff? Yeah. So these shading differences here are due to the sensitivity maps. You see these really dark regions here? We're basically dividing by 0 at those points, or it's dividing by something really small. To fix that, we're going to need better sensitivity maps. That's something to work on. We accomplished our goal. We're now using We're now using 1 gamma per coil, and that gamma is being set automatically. Pisco is a open source software product in MATLAB made by Rodrigo Lobos and his advisor Haldar, Justin Haldar, and it is excellent. It's also very sophisticated. So uncharacteristically for me, I might actually just use their code rather than recreating the method for doing it, which makes me feel uncomfortable. What are you going to do? Okay. Still getting a good reconstructed image out. Seems to be an issue with the toes. Where's truth? Yeah, the toes a little messed up, probably because of the sensitivity maps again. We're going to have to see what changes when we use like excellent sensitivity maps. But for now, at least this region up here, all this noise is gone with the SPIRiT recon. That noise is also present in here. It's just not as easy to see when it's not against the dark background. So we have a higher signal to noise ratio, I strongly suspect. Do we have any other debug codes in here? Yes. Oh! Shoot. We've been using a single gamma. Okay, may not. I might have to put that to-do item back in. Let's see what happens when we use 1 gamma per coil. Okay, this is an excellent result. Wait. This is an excellent result. This is using 1 gamma per coil. I think this should have been mean the whole time. Am I right? With this, I'm taking the mean of gammas, and here gammas is a value per pixel, not per pixel per coil element. So this should have been mean of gammas. Let's see what happens now. I think that was a bug in the earlier code to when we were finding a single scalar value for gamma. That, of course, gets addressed now when we're finding a value of gamma per coil. So we don't need this, but I think this is correct. Truth, MBR. Yeah, I think that's a better result, and I think that is the right result. And it took me doing this, finding the value of gamma per coil to figure out what this needed to be. Okay. Now finding one value of gamma per coil. Now finding and using. You just solve one problem at a time. I guess it was in The Martian. You solve one problem and then another. Is that right? What is a quote from The Martian about solving problems? You just begin, you do the math, you solve one problem, and then you solve the next one, and then the next. And if you solve enough problems, you get to come home. So is that in the book or is that just in the movie? Well, it's at least in the movie, and that's what I'm thinking. That's what we've been doing. We just solve problems one at a time, and our code is becoming more and more sophisticated and better quality. We've created something new. Seems to work pretty well. We're constructing a very high quality image with only 25% of the samples, well, 25% plus the auto calibration region. Yeah. Earlier this morning, I was thinking we had a long way to go. And right now, I'm not sure we do. I'm going to take a break. Maybe we'll see you all tomorrow. Until then, thank you for stopping by.